Okay, so let's break this up into little pieces and also chunk them up. Okay, so this is, okay, let me do 10 by 10. 1, 2, 3, 4, 5, 6. Okay, so I'm actually doing this so that I can actually simulate or visually show how data can be arranged. Right. So I'm going to assume that each block is 10 by 10. So 10 click, 10 click. Oh, no. Let's zoom in a bit. It's still not clear. I don't know why it's not clear. But there's one block and another block. Okay, so block 1, and this is the next block. Okay, so I've just broken it into blocks. Right? So the hard disk data is dealt in blocks, and when it comes into memory, it's also dealt in blocks. It makes it easier. But when you bring something, you put data on it, you can take something back. So it's easier to deal with blocks instead of how blocks are properly. Okay, so anytime someone defines a table, so for example, someone defines create table student, and you define some characteristics of the student, such as student ID, an integer, let's say F name, which is character, L name, right, and let's say date of birth, which is a date. Something very simple. Right. And let's assume that each one of these, each block is a byte. So let's assume that each block that I have here, so one block like this, right. Sorry, one okay. So each little square, right, say it's 8 bits, that's 1 byte, and then it's 10 by 10. The total block would be 100. So a total block contains 1 byte times 10 times 10. All right. So according to this little demonstration I'm doing, one block contains 100 bytes, and that is your student's definition. Right? Now, a lot of databases, when you actually create a table or call this command to create a table, there are some things that the databases has to do. Right? And in the background, it does have to maintain a dictionary. That will describe each of the tables. Right. If you have MySQL, so any database management system you have at all, so if you pull up MySQL, so while this is pulling up, the reason why it needs a dictionary is if you write a query, sometimes you wonder how to do the columns, because it has all the schema actually stored. So anytime you create a table, it actually stores the description of the table, the columns, everything. So when you write a query, you know that this one contains this thing. Then it has to update that description. So for those of you who plan to write your own database management system one day, that's one of the things that they will do. In the background, everything that is created, the tables, the artwork, write the description down.
So MySQL has started. Come on. Fast, 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 fast. Alright. So one of the commands you can run is show databases.
Show databases in MySQL actually shows you all the databases that exist, whether you can connect to it or not. And you can see that one of them is called the information schema, meaning that the database management system actually keeps all the information in one of the databases. Don't go in there and delete stuff. If you go to the website and let's say a Linux admin goes into his program folder to start deleting stuff. So this way it actually maintains all the information that you have.
So if we use information schema, right, so let's use this specific schema, and then we say show tables. Show tables shows the current tables that are in your schema. You can see that it actually has character sets, collations, column privileges, engines. So everything, it has a lot more stuff in the routine. So everything that you are, oh, there's even a table data set. Table. So it's the table of tables. Right. So for example, I can do select star from tables. Oh yeah, that's too much. Let me stop it. Let me limit it to 100 so we can get some information out. Oh, that is still taking a long time.
The engines are the different ways that data can be stored. Right. So in this chapter, especially as I go through, when different people are implementing how different tables are stored, you name them certain things. But those names actually correspond to a set of strategies that they have implemented. So you will see something like MyISA. It's just a module that describes how, or is going to implement how the database tables are going to be stored. And how you can access information. So you can see, for example, this table database, a table of tables.
Let me, so table schema. So there's information schema. Last time, one of the tables that we created was the test canteen, right? So let us find out how the database has actually recorded this information. So from tables where table schema is equal to test sample. Alright, so according to this,
the test sample has students, that's one table, student info and student tag.
Right, so that's one. I can also find out, for example, test canteen. Right.
And that database has customers. Remember this was one we did last time. So actually the database management system has a database, a schema describing all the information about all the data. So the database has database. It's an interesting idea, but that's how it works. So all the information he knows as a database, he's not storing it in that file somewhere. Often he's going to keep it in some table that he controls. So don't be messing around with the information schema. So that if I make a change, so someone was asking, what if I change the name of the table? So just to demonstrate, I'll change it back. But if I go to one of these customer, right, and I alter this, and I now call it customers now, apply. When I run this query, you'd actually realize it's updated it in its information schema. So tables are kept here on everything, all the objects, all the features.
So it's actually very nice. Okay.
So do people understand the first step? That when you create a table, the database management system has what? Record description of everything about the data. So that's the first step. Now, recording is the easy step. The second thing is the information that you have. How are you going to store it within the block? Right.
Now,
okay, so the simplest type of record.
that you can have. Oh, come on. Okay, I'll reduce this in size a bit.
Okay, the simplest type of record that you can have is
The fixed length record.
and this is just like if you were to implement a database management system.
I think we should put paper or something to give it friction.
Underneath the roof.
We'll go and sell paper to people.
Okay, so first is the fixed length record. I mean, if you were to make a database management system yourself, often the easiest way is to start with a fixed length record.
To say that each of these records will be a fixed length. Right. So for example, an integer. Most processors now use 32 bits.
So in terms of analysis, people who are wondering how do people know the size of the table and so on, you have to sit down, read some specs, figure out how large is an integer for this DBMS or for this processor. The most common now is 32 bits. So if you read any database manual, so if you go to mysql.com and you read your manual, they'll tell you how large an int is. I can't promise you that this will forever be the same, but well, maybe in the future we'll all be having 128-bit machines and you could all decide to move. But right now it's 32 bits. Right, simple int. Right. Hello. It varies. So, for example, this week I did create another database. Well, I mean, like students are registering, people are making mistakes. So you have to fix the problem. And I had a different idea of how to go about the process. Within 20 to 30 minutes, I make a database, copy this into but it all varies. It also depends on the difficulty of the task or how many things I bought. In class last time, you realize that within the 1 hour period, I almost coded what they have there. So that you have your customers, you have your food, you have your menu. Once I write the function, the next step is add a feed. That may take a while. But I mean, if you are, the problem with human beings is someone like me, I cannot go eternally. You want to be effective. In the morning I start work, fully work. So you may advise yourself how you work. How does working apply to you? For me, I wake up in the morning when I'm fresh. That means Saturday or Sunday, first service, come back. Good. If it's not good, because you're violating the Sabbath. I let you tell yourself that it's Sabbath. Saturday, and then Saturday you rest, and then the Sunday you do the other stuff. So there are ways that inside. I don't say go to SDA. I'm not SDA. But there are ways. So that means that on Tuesdays, that's why Tuesdays, Thursdays, I do not, because when I wake up and I have to do things for Thursday, so you have to decide what are the best hours for you. Some of them might be training your mind, but if your mind is fresh, you'll be able to actually do a lot. If you are tired, sleep and wake up. So it will take you some time, and you tweak it. It won't be one day. To focus or records, it's not one day. You do do something, they'll say, oh, this, we are thinking of some new ideas, and then you think of it and you update. But if you are being pushed, so if I'm being pushed and you want me to deliver a product, you should give me a little bit of research, I can go over. But sometimes you also need help. So don't feel like you have to do everything at once. Okay, so depending on how large the organization is, so especially even though we have mostly me going in, there's going to be a CEO coming to say, oh, you need to start thinking about this, but then I'll say, oh, this passport issue, or people are doing this, how do we solve it? So often there's going to be a discussion, let's start doing a software engineer. That will give you the requirement of what you have to do for a year. And so you will not have to work alone. But of course, it depends on the company. There are some companies where the person creating the database is the person like the tool, the person. So I've worked in companies where the database person, there's someone who, even though everyone is doing databases, there's an overall administrator whom, if you create a table, you have to go and show it to him and tell him, for example, why you are using 20 for the last name. And he will ask you, why are you using 20? You have to tell him, oh, give me a good application. Right. So there are some workplaces where there are levels, where you need to create a database. You can't just go and dump it. There are also some workplaces where the databases have been created, and the only thing that you are supposed to do is write queries. For example, the banks. They may not be changing their tables a lot, but there are a lot of questions about, okay, can we figure out who did this, who did that? You're writing queries, making reports. So it varies from workplace to workplace, or how mature the workplace is. So whichever way, and whatever company you go to, I'm sure you see some patterns and trends. Either someone says, okay, all the databases are created, you cannot touch them. Sometimes you cannot even write queries. The banks, sometimes they tell you can't even write queries directly. They will export and give you a copy of some list of fields and some data and say work with this. Because they don't want anyone to be touching the main thing. So it varies from this. Okay. So back to the fixed length record. Okay, so the first one I'm going to is fixed length. I also talk about the variable length. So I'll go through it. But fixed length is the simplest. So fixed length, if you see car 20 and such, fixed length means that the length of the record isn't allowed to change. So in consequence, the length of the fields are not allowed to change. So we also do talk about fixed length fields, something like this. Everything is fixed. So car is 20, last name is 20. And assuming that one character is 8 bits, that means this will be 20 times 8. This will be 20 times 8. A date, so I'll need to store, okay, so I need to store in here. This is interesting. Okay, so assuming that dates, so I'm going to go through like system design, trying to figure out how much or how many bits do I need to use for a date. Just hardcore. So a date, if I assume that a date, to make a date, so let me do it on this side so it actually shows up. To make a date, right, I need to store the year, I need to store the month, I need to store the day, right. A year would range from 0, okay, all the way to, let's say 9999, assuming that, you know, the world doesn't end by then, or it ends before then or something crazy. Right. But this is like the year 2K problem, where they designed the date and then they didn't consider that, you know, 99 isn't now. But I'm doing from 000 to 9999. So maybe in the year 9999, if I use this date format I'm designing, there will be a Y2K back, or Y, no, not Y2K, and a Y9999 back. Okay. So months goes from 1 to 12, days, come on, 1 to 12, days should go from 1, most days I've seen is 31, right. I'm going to bring up my calculator, right, oh, come on, exit, calc, right,
Okay, so this is scientific. Okay, there's even a programmer form. Nice. Do they have hexes and such? Okay,
So Microsoft does have a very nice calculator with a programmer view.
so people who are wondering how I got here,
View, and I picked programmer.
and what you can see here is it actually gives you option of how the information is displayed, whether in binary or so these are number bases. Hex 16. So if I want to be able to store 9999, right, you can actually see the bits pattern.
So that's a bit pattern for 9999, meaning that I'll need 4. So counting from
This end 4 4 3,
right. So that's how many bits? 11. 11 bits to store the 9999.
right? Does this be always on top? No. So this I'll use 11 bits. Right. Now what about the month? I just need to store. Okay, go back to. Oh come on! How do we even clean this? Oh, C or something. Okay, there we go. So 12.
You can see that the bit pattern for 12 will fit in what? 4 bits. So I just need 4 bits for this.
And for 31, I clean this again and I do 31. You can see the bit pattern for 31 is 1111. Since the information is, I can say, okay, I'll use just 2 bytes. Oh, sorry, 5 bits for this. So let me just compact to 5 bits. 5 bits. Are people understanding what we are doing?
We're trying to figure out the information that we are storing, how are we going to represent it. So at the very lowest level, people who have to design how information is stored, they have to do this type of work. Right? So that means that for my year type, this special year type, is going from 0 to 9999, coverage 12 months, 31 days.
I need 11 plus 4 plus 5, which is, okay, 20 bits. Right.
But my information is stored in bytes. Right? So how many bytes am I going to use for this?
So 8, 8 is 16. I'll use what? 3 bytes. So 3 bytes, that means I'm going to be using 24 and waste 24 bits for sorry. Okay, so 24 bits, 4 of them are wasted.
Do you understand how I got here? Alright. And the reason is, if I'm storing a date, I'm going to be using 3 of them, and it's just like the block. Even if I'm using just 3 of them, because of how the units are, I'll just wait for a unit. So the main unit of operation for a lot of things would be the bytes. So in this case, I have
3 bytes. So 3 times 8. And if I add all these up, this will be 32 bits. 8 times 20, 116, 116. Oh wait, I have to be careful not to be mixing this up. 20 times 8, 20 times 8. Okay, yeah, you're right. That's 24. So in total, I'm going to be using 376 bits. So this is all in bits. Come on, shrink a bit. Bits.
right. And to get it to bytes, I'll have to divide by what? 8.
Alright. So this is equal to this over 8. So it means that for this specific one, I'm going to be using, that means if I store 1 student, 1, 2, 3, 4, I'm going to color this as slightly differentiate, and 1, 2, 3, 4, 5, 6, 7. Alright.
So that means that each student, that's how much I'm going to store. Right. Now, the next 47,
So let's see. The next student I store can be here. Let me color this slightly differently. So this 1, 2, 3, 4, and my next 4. So I've done my first record 47, my second 47. Right. So this then comes to the question of, are we going to allow the record to span across? Right. So spanning. So the book talks about spanning, but spanning is something that you also encounter and if you want to store data. The question is, if I want to store the next block, or the next record, should I store it? So this is 1, 2, 3, 4, 5, 6. Right, so I store 6 here, and I store 14 and 1. So this is one approach. Or should I totally? So this is non-spanning. Totally move. Oh, sorry. And start the information storage.
All on. So these are design questions. Should you span or not span? So in terms of storage, which one is more compact, spanning or non-spanning? Right. So the spanning, you realize, will be more compact. But the problem with spanning, of course, is that now even the location of where things start to drop and vary became over time. So a lot of things, it's about trade-offs. So if you have to compress, you could use some of these techniques. But a lot of the computer systems, when they actually say they are compressing data, they will actually also do some sort of compression. That will be zipping, not the actual zip, but other techniques to compact the data. Right. So for example, I could go through and decide, okay, maybe all my bits here are just using 99. That means I can throw away a few bits. But often, for most systems, what they do is when you actually say you want compression, they would apply some compression algorithm, right? Not zip, but something a little bit more simpler, so they can zip it up. Right. You will also see the same ideas. So the question is asking, the new hard drives, some of the new hard drives can automatically compress and automatically encrypt. Meaning that when you're actually storing data, you actually shrink it a bit before it comes in. So there are different ideas and different techniques. Right. So this is one. First one is spanning, and the second one is non-spanning. So in exams, I do like to ask you questions. As you can see, you can be given a description of the table. And that means that now that I know that each record is 47 bytes, if I tell you that there are a shared system record as we have, including some of those who have left, it's about 1,500. No, way more than. Forgot it. Not good. Okay, if I say about 1,500, now they're going here. That means that if I ask you how much space, so the question, so this is just a mock question. Slides. Okay, so how much space do I need for 1,500 students? Right. So this is a very interesting question. How much space do I need for 1,500 students? Does anyone know how we'll approach this? How much space will I need for 1,000 students? Alright, so that's the first step. That is, we have to, sorry, totally silent. Okay. We have to know that, okay, each student, 47 bytes. So therefore, would be 47. Yeah. Don't worry, I'm listening to what you're saying, but I'm also trying to type it so that it shows up. You can all follow. And have you done the calculation yet? Or okay. Okay, so that's the other very, very important question. Okay, so this is equal to this times this. Bytes. And how many megabytes is this? So as you can see, data actually is not that big. A lot of things about data. So even though this looks like a lot of students, often it's the additional information that we add and all the different ways that we want to store the information that makes it so take our time. And the processing also, that as different processes are running, those data operating systems, we start talking about processes being switched in and out of memory, right? So when systems are running, you may initially think, oh, this is so small, but other things would also be giving the data. Maybe making a copy, sorting by last name, making a copy, sorting by first name, and so many things. All right, but he raised a very important question. So in Windows, if you actually right-click on a folder or a file, it's your properties. Let me see if they still do that. All right, so you can see that there are actually two sizes that are being provided to you. Size and size on this. Did you or nobody noticed? Just in Windows, admin. Almost always the same. But it's actually explaining to you that the actual size is varying from how it is on this. Because on this, certain width or something else may apply. But sometimes too. So in this case, it means that however it's being placed, you have 8, 6, 5. Oh. Okay, so you have that much. It's too much. But you can see that when it's on this, it's a little bit bigger, right? Yeah. From here, from the 9.5, you can see it's a little bit bigger. Right. If I do this compression, like he's suggesting, if I do compression, they'll try and compress it, zip it in some way before it goes to this. That means Windows will be in charge of, anytime you save a file, when it's actually sending to this, they will compact it as much as it can before it sends it to this. Right. Okay, so data, I think what you see, and there are some people actually asking to do projects around big data. Human beings, if you give us, I have, let's see, this is 500 gigabyte hard drive, but my plan is to buy 1 terabyte next. Because if you give it to me, I'll start storing. Now I'm thinking, wow, I can have Windows and Linux and Fedora, CentOS. There are many dreams I have for my house. So the moment you give me 1 terabyte, I will fill it up. And you give me 2 terabytes. If I think my deal, you give me 2 terabytes, I'll be okay. But I know some students who keep a whole lot of movies. Last semester, people asking me, oh sir, I have 2 terabyte hard disk. It's not enough. What should I do? Can I shrink it? And often the movies are already compressed. So there's no shrinking. You have to go and buy another one. So human beings manage. And you can actually see if you compare old video games. In the old video games, you could, and that time the feeling was still there. You could still enjoy the thing, even though it was blocky and Mario wasn't so nice anymore. But the moment you make another processor or computer that can do graphics, the developers say, wow, they're going to use all of this power to do more graphics. So the useful work, and some people have actually asked that question before, that aren't computers able to, I mean it's possible to put that way, to be efficient, small, compact, do a few things. It is possible. But the question is, how many of you like command prompt browsing? Some people say, oh no, I don't, but I showed you in OS, command prompt you can browse. But see now, people are telling me it's not nice to look at, just because you don't see a logo. But you can get your work done. You can read your email. You can. It's not that horrible. Okay, so human beings will use the space. That's the answer. Human beings, if you give them the space, will use it. Same for here, they give us a new server, all of a sudden I say, wow, the reports that I wanted to run, so you know, she can do it in real time now. The backup can run in less than, I think less than 15 minutes. You can restore in less than 15 minutes. So the moment you give me the power, I will use it. Right. At the beginning of the semester, I realized that there was some complaints about people couldn't log in. When I got the hard disk, I was so excited. I filled it up with logs because you are, oh, do I even, okay, let it do whatever I want to do. And then I realized people couldn't log in because some of the logs were unnecessary. So I went through the things that were unnecessary, I took them off. And then people could use the space when they log in. So human beings, if you give them space, they will use that. So as a software engineer, or as a software engineer, or any engineer of that form, you are trying to always balance your requirements with what is available and what you can do. Of course, then there comes the marketing, the branding, and the selling. Right. So the question he asked before, how this information is stored, is important. Right. So there are two ways. We can either have spanning for this information or non-spanning. So this is my actual size. So actual size is in this case 70500 bytes. Right. If I do spanning, then I have to ask myself, how many blocks am I going to use? Right. So spanning uses, and a block is how much? Now look at this one. A block is 100, right? A block is 100. So if I'm going to figure out how many blocks I'm using, right? So just to figure out how many blocks. Spanning the size on this, I have to figure out how many blocks I'll use, and then I'll see that is the size I'm actually using. Right? So if I take this one, each one is 100. So if I have this much data, it will be 70500 divided by, why doesn't it like me anymore? Oh, it ran away. Let me see if this works. Okay, divided by 100, right? Which is actually, so we've already calculated it. Okay. So this is data size divided, oh sorry. Why does it, every time I hit this slash key, or is it misbehaving? No, it doesn't like that. It doesn't really like that either. Different tricks. Divided by block size. And you got my answer? 705 blocks. Alright, so according to this, I'm going to be using 705 blocks. It's very nice, it's very round. Sometimes you may have a little bit of an overflow. Right? If you have an overflow, so if we were maybe 70501, even one, it means that what? I'll be wasting one more block. Not wasting, but I mean it's overflowed to the next block. So I've used that block for this table. Right? So usually every table, the information will be stored in a set of blocks. It's not nice. I mean, you could envision mixing different tables in the same block, like that, sample records, and then you can do that, but it's just messy. It becomes very messy. So in this case, if I didn't use 70501, I would have to say I'm using 706 blocks. Are people understanding? So
this one was found every block can contain I think
so spanning is this one. When we are doing spanning, because we are spanning, let's divide whatever we have divided by. So for example, in this case, there are 3 records, right? 3 records is 47 times, so 47 multiplied by 3. And that's equal to this times, sorry, 141. Right. And if you ask me, how many blocks am I using? So I'm just going to do the same thing for this one. So this is interesting. Please watch. So if I had just 3 blocks spanning, so calculation without doing a diagram, I'll say I have 141 bytes, and if I want to know how many blocks, that means it will be 141 divided by 100, and this is actually equal to this divided by 1.41. But I won't say that I'm using 1 block, because I'm using part of the second block. So this would actually be equal to 2. And in the textbook, what you'd see, so ceiling, right, which is actually, I think you have that here as well, ceiling. So ceiling is the next integer. Come on.
I don't know why today this thing is really, really messing with me. Why? You have entered too few. Oh, sorry. I think significance. Oh, that's not good. So I've forgotten some of these functions. Okay.
Ceiling would round up. Floor would round down. So in the text, you will see this a lot.
In the textbook, just a sec before I take your question. Yes, the normal mathematics rounding up.
So 1.41 round up. Round when you say round.
Okay, so some people have. Oh, it's normal mathematics. When we say round, the normal idea for when people say round, you have to ask, how am I rounding? Right? If you say the median approach, you say, okay, if something is half and above, you go up. And if it is below half, you go down. Right? So normal rounding, half, go up, less half, go down. Right? You also have floor. Floor just means anything not whole, yeah. Round down. So floor, that means if I say floor 2.999999, you come down to 2. So that's floor, right? And ceiling, that means that even if I say ceiling of 1.0, go to 2.
Right. So that's what I meant by when we are actually computing block information. A lot of the book, the notation, and
The notation in the book would look like this, where you'd say there is some, trying to write it out, some variable x, and it's equal to, and they'll say the ceiling of y. That's how they'll do it.
so ceiling, you see a symbol that looks like a half block. This is also seen in discrete mathematics. Just means to pull it up. And there's the inverse where the thing is below and you pull it down. So if you see the notation in the textbook, that's what they mean. The question and the okay, so currently we're actually using mathematics to express what we are doing. So the hard drive doesn't actually translate. Your program will have to decide whether to translate or not. But we are saying in this case, where we have a record, we can't throw away the record. So what we are saying is we're actually using 1.41, but in actuality, the 41, that whole block, that the 0.41 is in, all belongs to this record. So we are taking 2 blocks for this.
So that means that size on disk for this one, as you see on size on disk, would be 200.
Right. Not 141. Actual size 141. Size on this would be 200. I'll give you an alternative. Okay, so I'll take this one. The next question. Okay. Okay, so block size is influenced by the hard drive design and also the person writing the code.
Right. If you take any, I can try and bring one of these. Hopefully I won't format this. Okay, maybe I should do right click format. I won't lose my, oh, not eject. No, I didn't want to eject. Go back. These are weak yet. Okay, it's back. So if I do right click format,
You can see there's an allocation unit size. Right. So the hard disk or whatever system you're using, it has a way of blocking the information. So usually we use multiples of this, either half or the same unit. Because if let's say your hard drive, 100 was small, but I did 100 so I can quickly do something small. Right. In actual sense, it will be much bigger. Right. So this is around 4096, which is like 4 megabytes. So depending, and these are the options that this hard drive provides. from 512 bytes all the way. And that means that this is now how it's going to be chunking up the information on my pen drive. And for the hard disk as well, when I'm formatting, I could have these options. Okay, chunk them out in this way. But I realize that it's actually multiples of something. There's a core unit that is doing multiples of, in this case 512. So the next one is actually just 512 times 2. 512 times 4. So it has a minimum block size. It has a way that it deals with information. That's why I said it's like a book. If you do it in pages, and you tell me, okay, you want to have blocks, I'll say, okay, maybe 2 pages, or 4 pages, or 8, so it will still be multiples of 1 page. So in this case, the hardware does influence. Okay, that means that now the hard disk would be, or in this case my pen drive, would be using that as a way of grouping the information. I mean, when it's bringing, it could be bringing in that much, right? So whatever DBMS you have that's running, you also have to figure out what's the, I mean, it's the OS read this out of the system to say, okay, your hard drive that's connected, these are the parameters. So it's possible for a DBMS that's running to figure out, do I have quad-core? How much memory do I have? Actually, through this chapter, those are some of the things that we are pointing out. That information is stored in blocks. So it means that for a DBMS system to actually run, right, it actually has to know how much memory do I have to use. Even if it's doing sorting, it has to know. So it can plan the strategy for sorting. And we'll see this later in class. Right. But start with the block. Right. So memory is a factor, hard disk is a factor. Though for a lot of the questions in the textbook, we assume that there's a lot of hard disk space and worry about moving data in and out. Because well, if it doesn't fit, it doesn't fit. Right. But hard disk is also a factor. So DBMS, how much does it use? Right. So if for example you try to install, say Oracle, not bad mouthing, but Oracle, they would say, okay, I want to use maybe 1 gig of memory, and if you don't have 1 gig, sorry, they won't install, right? Or 2 gig or 4 gig. So any operating system, that is the person who wrote that software, when it's installed, he will check to make sure you are meeting the requirements. Meaning when he's running, he wants to have that much memory in order to run efficiently. You could force it. Some people do tricks. They will put in extra memory. After they install, they remove it. They think they are tricking the operating system or tricking the DBMS. It will just not run efficiently because it will try and run and it doesn't have enough memory to do what it needs to do. Right. So the person who creates, so the hardware is made, OS is made, the DBMS will have to read these parameters and use it to guide how it's arranging its information so it's efficient. Right. Hello. Some of them, it may also have to do with how the hardware was designed. So even though I see the allocation size, it's possible that maybe if I increase it, the hard disk may not be as efficient enough. There are a lot of things that we may try and do that may not be based on hardware. So in OS, we start talking about hardware and the OS. So a lot of things, it's about fine-tuning. Right? So there's a tablet that someone left, relative left. There's another tablet. Since yesterday, it's only down in 98%, which is really, for me, I was very impressed. Wow, this is nice. Very few things installed, doing nice. Right, so that means whoever made that tablet, sell to that person, do that all the different parameters and take them into account to make it efficient. So some things, it's not just going to be pick this out of nowhere. You have to be, take it, test some of the values, and see if it will actually work. And as far as hard disk is concerned, those people who are making device drivers or trying to optimize how hard disk and other drivers behave, or hard disk drivers and other drivers behave, or even I think recently when they changed how operating systems boot, a lot of people go and try and add an operating system and realize, oh, you know what? Even though they are promising that you can boot any operating system, it doesn't boot. And we saw this, I think, in OS part where VMware and VirtualBox, some of them couldn't boot Windows 3.12. I mean, it's virtualizing some things, but maybe the behavior of that operating system, the hardware is not compatible. It won't boot. Which is why Windows and such, before they release a new OS, they realize that they will have it's like a press conference, and then they will have a separate developer conference. They give out CDs so people who are actually going to make software or make hardware can try it out, make sure. So there's not a magic bullet. So this class, I'm not saying, oh, it's 100 bytes. You have to figure out the question. One, this byte size, is it going to work? Right. And what are the factors involved? Okay. So you realize that with this three records approach, for this one, even though I am still not spanning, so this is the non-spanning approach. I am not spanning, but in this case, I'm still using what? 2 blocks. So for this, for 3 records, spanning or non-spanning, no difference. Right? I'm going to use 2 blocks. But let's continue with the big problem, the big example we had. So that is 150 students. Let me move this down a bit. Sorry, 1,500 students. If we were going to do non-spanning, so let's do the non-spanning approach. If it's non-spanning, right, that means that I first of all have to figure out how much data can I fit on one block before I can figure it. So that means that every 2, I'm going to use this much, right? And so in this case, right, I have 70500, right? Sorry. I'm going to divide this by 2, right? Because I want to know how many blocks. So you see the strategy is slightly different. In one case, I just said, whatever the block size is, let me divide, and I'll have my total block. In the second case, I'm going to say, well, since I know that every 2 of these will take a block, I can just divide it by 2 to figure out how many blocks I need. So if I divide this, 100, 100, 100. Okay, no, sorry, that was not the right approach. So 47, sorry. So 47, let me start this way. So 47 times 2, right, is how much? 94, okay. That means 2 students per block. So the non-spanning approach, we turn it the other way, where we try and figure out how many. So in this case, that means I'm going to be using, someone gave me the answer a while ago. This, oh, come on. 94. Okay, so I'm going to be using alright, so 94 bytes in each block. So I have 94 bytes. That means that now I can just divide the 70500 by 94 to figure out how many total blocks I have. Right. I hope that people like this side of the class. It's very, very like proportions. It makes sense. Some people don't think it does, but I think it makes sense. Okay. Alright, so in this case, oh wow. So non-spanning I'm using much more. 750 and spanning I'm using 705. So you realize that it's a trade-off. If I'm not doing spanning, so if in this case, it's actually very simple. So someone asked me, well, will we use a hard drive? Yes, I'll use the hard drive because this seems like a simple strategy. 2 things. Every time I pick up a block, I know where the first one is, where the second one is. In this spanning approach, it's more compact. So maybe for something like a mobile, it may be useful. That's what you would think. But then you also have to realize that I also have to spend some time doing the processing, some time figuring out where I am. And you can actually write a simple math function, tell you where to predict where the position is. But it's just rounding and figuring out what the offset is. You can easily do that one. So it depends on how much processing you want to do. In one case, someone can say, if you ask me, for example, where is the location of block number 4? I just know that I go straight to block number 4. He will always be in this position. Right? But in this case,
block number 4 starts in a different position. So the blocks are starting in different positions in all the blocks for the span because it's shifting offsets and so on. So it's a trade-off, right? Even though I seem to be using more memory, it's simple, but if I use less memory to store this one, it becomes a little bit more complex. So there isn't one I have to say, always use one thing. The important thing for all the CS courses, including OS, well, this course, is knowing what the different trade-offs are. We discuss. You can do something this way, you can do something the other way. It's not to say always do it one way, but to say maybe if you meet a certain kind of criteria, you have to shift. One way is better than the other one. For a fixed configuration, yes, one will work, but the next time, it will not work. Right? So if you take the mobile phone operating system, a lot of people, what it's doing, it may not be as much as, let's say, a laptop, what it does, but they may use some old ideas, and it works for the mobile phone based on the constraints they are facing. Right? Meanwhile, if you brought it to a full desktop, people may not be satisfied. They'll say, well, come on, can't you, for example, some mobile phones, as I said, you can't do, multitasking is nice, but multiple windows is not so comfortable. So different people have different ideas, right? So the older ones, as I said, they could even do multiple windows. But the same applies to old computers, very, very old computers. And even some versions of, how many operating systems, some versions of some operating systems, you can only run 2 or 3 things at once. Maybe your Explorer. Some will usually you can only run one thing. They're running one program. But it's nice. They will say, you know what, this is very cheap. $100. You can only run maybe Explorer, or you can only run Web, or you can only run, so pick one thing to run. And that's it. When you want to stop, you kill it. But for the memory involved, it makes sense. Right? So it's not always one thing. Okay, so actually it's the reverse. Often the block size, remember I said the block size is being determined by hardware behavior, the OS. And so that means block size is often fixed. And then the DBMS will then have to decide which approach am I using. So in the first one, we're actually using fixed length records, which we said car. Car is fixed length. Right. But that means my only options are how do I either spanning or non-spanning. Right. So that's the first case. So this is hello. Alright, so non-spanning, our trick was to figure out how much data can I fit. So it's like I'm taking 94 of every time. So I take 94 and I put in one block. Take the next 94 and I put in the next block.
Yeah, so what happens there is like
so that means it's wasted.
you can't even
You get wasted, yes. And as a programmer, you try and say, let me go and extract some other information in there. But that's
one is, we know we don't have a place where we are taking the two squares into one block. You think like we need to get the location right. So that we just do what split it into 50-50. And then assume everything is right. So that you can get the
okay. So she's actually optimizing it even further. She's saying, if I know I'm wasting this space, then okay, so that means you actually make a very good system programmer then. But you're thinking of different things. Right. So this actually is very nice. So that means you say, oh, you know what? I'm wasting time doing this. This is a nice position. Nice.
So you always know.
Yes, but in the first one I would as well. So this is much cleaner. I do understand it. So a lot of these things is just the natural way. If you are lost in an exam, just take a pen and paper, sketch it out, use your natural ability. Right. The only thing courses do is that we give you a lot of ideas that people have compiled over time. Right. So right now, most people know about computers. Some people even know more about computers than some people who received computer science prizes some years back. Because now it's in the textbook. You compress it, present it to you in a nice format, and within a few minutes, you have all the ideas. Right. So, nice extension. Okay. Now, let's talk about the next iteration. So, we have seen that we can have things and we can try and compress them. Right. But this is not the only way to store information. And some people have been using varchar without even knowing why varchar came. So let's go on to the next idea. Right. And that is, instead of using char, which are fixed variable lengths, we can actually start using variable length fields. Like a varchar. Right. So now, if I'm doing a varchar, often we'll ask the question, okay, now I don't need to use all 20, right? Are people understanding the idea? Right? So with varchar, so that's why often people just say varchar. But varchar, now the idea is, well, I don't need to use all the 20. I can now use some amount, right? So if your name is just maybe John Who, John 4 characters, Who 2 characters, I'll just take 4 for the first, 2 for the second. Right. Now, in an exam situation, if we give you varchar, often it's nice to ask the question, after even in real life, to ask the question, what is the average first name length? Right, so that you use that for the calculation. So in varchar scenario, the worst case would be getting of 20 characters. Best case scenario, maybe just 1 character, not 0 characters. That's kind of strange in a way. Right? So if you said, okay, now it's allowed, then maybe you're allowing 0 characters. Right? So the idea is, if we know, the book doesn't say this, but I think it's, in real life, if you are doing this calculation, you have to ask the question, what is the average length of a first name? Which, if you have some data already, or some sample of information, you could actually run that query. So if I use my test canteen, and select star from customer, oh, I called it customer something, customers now. I have to change this back. Alright, so select length of username, length of full name, alright, so for databases you can actually perform these statistical queries, so to calculate and figure out the length. And of course you can also use your min max average to try and figure out if you have a sample of information. But note that you don't need to have a full DBMS running to do this computation, right? There are many sampling techniques, so you can maybe pick some random ones and do an average and see what is my average size. So that's in real life. So we'd like to know how much on average, right? So I'm just going to assume some average values. So let's assume that most people's first names are around 10 characters. Right? So even though this is worst case, we'll look at the average case. Student ID, we are still using our 32 bits. Are people trying to kick us out? They have a class here. Now, oh, their classes. Oh. Okay, so I'll just do the small, not the whole thing, but the average idea. So if you look at first name, last name, date of birth, student ID, you are still going to use that amount. But for the date of birth, again, we are still going to use the same because date is date. But for first name, last name, we have to ask ourselves what's the average case. So assuming I assume that, okay, average name is maybe okay, let's say about 5 or 6 characters. I know people have longer names, but let's say on average we have about 7 times 8, right? And last name, since people have a lot of hyphenated names these days, say about 15 or 14 times 8. Right? So you realize that when I'm doing with varchars, I actually have to consider the average. So that's in practical terms. But the other thing that we are missing when it comes to varchar is with variable length characters,
there are many techniques or strategies that programmers can use. Right? The first technique is you can put a separating character, maybe a noun or a character which isn't used within your data, so that when you are reading it, you can figure out where the first name ends, where the last name ends. Right. So for example, in my file, I could have maybe student, so the first thing is some number representing my student ID 2013, some character Kwejo, some character Jimfi, some character, and then I store my dates, and so on and so forth. Alright, so you realize that what you can use, just as in programming, where you can have a character to indicate where something is, you can use this approach where if something is variable length, it means you can no more predict. So first strategy, use a special character. And the second strategy, programmers, use the, no, not, so we are still trying to use variable length. Okay, so you can use the what? Okay, so not a temp, but a pointer. You can keep a number representing where to start off. Right. So for example, that means that I can store 2023, 2013, Kwejo, Jimfi, 19, and so on. But then throughout this, I would note that Kwejo starts from the 9th character. So 9 and 1, 2, 3, 4, 5, 6, 7, and Jimfi starts from, okay, this is find K in, wow, this is not like an Excel class to write. Find G in this. That means that I'll store 2 extra numbers to indicate where the offset is. Right. And programmers, last option, any other technique, you can store a variable in. Okay, so that's another one. So you can what? Record the sizes of each. So to say this one is, so that is to say this one. So in this one we are using, so saying pointers, can use size offsets, sizes, to say, okay, Kwejo is 6 characters, Jimfi is also 6 characters. Right. So that means after I read my int, I know more techniques. Any other? No, you can also use your, yes. The linked list. You can also use a linked list. That means that when you get to the end of one variable, you could have an indicator showing you where the next one is, where the next one is. Well, I think that you have all the techniques. If you read this chapter, you actually realize that a lot of the things that are being talked about, you know it in some way. You are reminded of it. Linked list, I'm sure you all know it, but he has it on a fingertip. That's what I mean by, in an exam scenario, you'll be assuming, so don't let us down. We'll assume that in an exam scenario, because they are much more closer in his memory, he'll bring it out much quicker. And you'll be moving at a very fast pace. That means that if you've forgotten, that's why we say the courses actually are related. So in this course, you can see there's some discrete math coming in, some statistics, a little bit. But all of these, they accumulate. Some data structures, algorithms. And the algorithms, I know some people think, oh, maybe I'm not taking algorithms. But you did programming 1, programming 2, programming 3. In all these classes, the techniques you are doing there, they are algorithms. And even these ones, they are algorithms in a way. Right? Because it's showing what are the different ways I can do things. And what are the different speeds and sizes. They are all algorithms. So the techniques, you must remember them. So you can what? Use them. So I didn't take database when I was in school. I skipped this course entirely. Although when I got to grad school, I said, oh, this is a nice course. Then I took the advanced version. But yeah, so undergrad, I didn't take database at all. And I didn't do web tech at all. And I didn't do Java. No, the thing is, you can skip. It's computer engineering. But between the mathematics and the system programming, C programming, you have the techniques. That's why sometimes I say you may not even need to take e-commerce. I know go to e-commerce. But some of the companies formed by students who are running successfully, they did not take e-commerce. I know some people who stayed extra year and came back just to see e-commerce, but some people did not. They took the web tech, they practiced it, and they moved. They built their shopping carts. Right. Same for database. You can take database and skip advanced, assuming that your discrete math is remembered and everything is still in your mind. You may take just a few classes, like the first 3 years. Keep strong and you'll be fine. Don't say that. I'm saying you can skip this course.
So
you can skip this course. But I mean, if you take this course, the advantage is I will remind you of all the things and link it up in a nice way. Right. So since you've forgotten a lot, please come back and let us continue. Alright. So please start reading through the chapter. We'll continue on Monday. This is chapter 17 of the 6th edition. It's 17. But the name of the chapter, this storage, basic file structures, and hashing. That's the name of the chapter. The name of the chapter hasn't actually changed. The location has changed, but the name has not changed at all. Database quiz. Yes, we should have more database quizzes. I'll send out an assignment test. Finish your, what's it called? Your functions. Finish that one. I'll send out an assignment. But any quiz will be based on calculations, hardness, operations.
Sent you an email. I uploaded my work for marking, but I've made some changes. I want to upload.
You did the send for marking. I thought that it was just